Now, before we go for the first break, I'm pleased to invite our next speaker, whose name is also guest. His presentation is titled Resilience in the Face of Adversity, the Paradox of Singapore's Coral Reefs. This will be presented by Dr. James Guest, who is a senior research fellow from the Nanyang Technological University. Dr. Guest is a marine biologist with almost 20 years of experience in conducting research in tropical marine environments. So let's find out more from him how our coral reefs are faring amidst coastal development and elevated rates of sedimentation and eutrophication. Dr. Guest.
Okay, thanks very much. For those who don't know me, I've been doing work here on and off for about 15 years on Singapore's reefs and reefs in the region. And what I want to talk about today is sort of a paradox of how we maintain reasonably diverse reefs in a really sort of adverse environment. So I'm going to start off with the acknowledgements, going to come backwards here, and sort of basically some of the data I'm going to present here has been collected by a group of people from different organizations, so a real collaborative effort. Starting off with Chow Lok Ming's group in NUS, and particularly Jeff Lowe and Carrington, who used to work in his lab and are now at NPARTS. So some of the data that I'm presenting, they collected most of that data and have been custodians of it for the last sort of couple of decades. And then the other group is Peter Steinberg's group from UNSW in Sydney, and he's now sort of straddles Singapore and Sydney and works partly at NTU and partly with UNSW. And then we also had David Feary, who came from UTS in Sydney. And then lastly, me, I'm the most sort of promiscuous of everybody here, because I've worked in 3 of these organizations and I collaborate with NPARTS. Okay, so whenever I've jumped in the water with a researcher or a student, either from here or from overseas, for the first time when they jump in the water in Singapore's reefs, the sort of reaction is always the same, that people are really shocked and surprised by the abundance of life and the diversity and colour and so on. They just don't expect to see what they see here. When you look at the sort of diversity and abundance of life here, you kind of makes you think, wow, these reefs may be quite resilient. And in addition to all the different coral species and fish and so on, these reefs are capable of regeneration. They spawn actively, the corals spawn every year, and we've sort of documented that now for the last, since 2002. So that does kind of give you an indication that these reefs are probably resilient and capable of recovery. And that's surprising because when you look at the sort of conditions that the reefs have to live in, they're very adverse, they're very unusual, and I think Karen did a fantastic job of sort of summarising all the different things that get thrown at Singapore's reefs. But basically it's one of the busiest ports in the world. We have these huge offshore oil refineries and a great deal of sediment, and then of course all this sort of massive amount of reclamation that's gone on over the last sort of 50 or 60 years. And so I think the reason why people are so surprised at what survives here is because of sort of some paradigms that exist both in the popular and the scientific arena. And sort of in the popular arena, people think that coral reefs are very fragile and kind of will wilt at the first sign of an impact. But that's really not true. Corals and reefs are actually naturally very resilient and very dynamic. And they've survived for millennia and in the face of all sorts of disturbances and impacts like storms and typhoons and so on, and predator outbreaks and whatnot. In the scientific arena, there's also this sort of paradigm that when you add human disturbances onto this natural disturbance regime, then you get a greater chance of a phase shift happening. And by a phase shift, I mean the reef going from one state to a completely different state. So typically from a coral-dominated state to a macroalgal-dominated state. So basically going from covered in corals to covered in seaweeds. And that is particularly the case when you get reduced herbivory. So basically when you fish out all of the parrotfish and all the things that like to eat seaweeds, then there's a much greater chance that when a disturbance happens, then the reef will shift to this algal state. And the reason why that happens is because when you get a disturbance, you get space cleared away, there's no corals living on that substrate, and new corals want to come in and settle and grow, but they find that very difficult to do when they're competing with seaweed. So these herbivorous fish play a really, really important role in most reefs. And there have been some really well documented cases of these phase shifts around the world, and people are really concerned about them happening more frequently. The most famous is from Jamaica, this study from Terry Hughes, a 20-year study of reefs at different depths. And what you can see here is coral cover going down from, in some cases, about 80% of the substrate covering coral to being less than 20%, and then at the same time, seaweed cover increasing dramatically. And that this is not just restricted to the Caribbean. This has happened in the Indo-Pacific too. So there's a sort of wonderful pair of pictures from the Great Barrier Reef, from an inner reef, where in the sort of late 19th century, this whole area was covered in corals, and then in exactly the same spot, about 100 years later, it's just covered in seaweed and sediment. So what we wanted to do in this study is really to kind of have a look to see whether reefs in this very impacted environment can be resilient to change. And you know, the reason we wanted to do that is because people have studied resilience in a lot of different areas, but typically they've been studied in areas further from human impacts, areas that are well managed, have low populations, and so on, small populations. A lot less is known about the resilience of these very impacted reefs near big human populations. And the reason we could do that is because a really nice long-term monitoring study exists, a data set that goes back to the mid-1980s, so it was started by Charlotte Moon's group. And I was able to sort of get some access to that and start playing with it, which has been really fantastic and really fun. And then in addition to that, what we wanted to do was quantify the extent of herbivory on these reefs, because we didn't really know anything about what role fish herbivory is playing here. And the surveys were done at a range of sites in the Southern Islands using standard methods of benthic line transects, and they were done at two depths, at the reef, sort of upper reef slope at about 3 meters, and a bit deeper on the reef slope at 6 meters. Okay, so here's the initial results. I'm going to take a drink of water before I carry on. And what this is a graph showing change in hard coral cover, that's the blue line, and macroalgal cover on the reef at the shallow site. And I guess the main take-home message from this, and what's surprising, is over this 26, 27-year period, coral cover really has changed a bit, but it hasn't declined. So you go back to that Jamaica graph where you just see this big decline. It's nothing like that at all. And similarly, seaweed cover, macroalgal cover, also hasn't increased. So there's really no evidence of this kind of phase shift happening or a big decline in coral cover. The other thing that you notice about this graph is there have been some periods where coral cover has dipped. One here in 1998 and one here in 2010. And those dips coincide with two big thermal stress events. So it's when there was an El Nino year and the water temperatures got very hot, and corals went through a thing called bleaching, which is when they lose their symbiotic algae and they get very stressed, and if it carries on for a long time, they die. Okay, when we go to the deep sites, it's a slightly different story. So clearly, at the slightly deeper sites, and bear in mind this is only 3 meters deeper on average, coral cover clearly has declined from about sort of 45 or something % in the 80s to less than 20% now, and that seems to be a sort of a steady decline. However, macroalgae hasn't increased. So again, even though coral cover does seem to have declined at the deeper sites, it's not a phase shift from a coral to an algal-dominated system. So that kind of indicates that there might be resilience, at least at the shallow sites in this system. So, but to look at resilience, we can't just to show resilience, we can't just say, okay, things haven't changed. That just shows stability. When we talk about resilience, what we're talking about is the ability of a system to sort of absorb disturbances, absorb change, but maintain its structure and function, and to sort of recover within a reasonable timescale. And one way of looking at that is to use these sort of multivariate plots. These are called multi-dimensional scaling plots. So if you've never seen one of these before, don't be frightened. They're actually very straightforward. Essentially what this is like a map. Just think of a map of Singapore. And every point on the map represents a sort of a piece of data, and each one represents the sort of community structure. And when you have 2 points which are very close to one another, it means that those two things are quite similar. When they're very far apart, it means they're very different. So with this, what you can do is look at the change over time, and this line represents the change from one year to the next of the benthic community structure, and this is the shallow side here. And so what you can see is, remember that there was this disturbance that I told you about in 1998, that was the bleaching event. So this is what it was like just before the disturbance event. This is what it was like during the disturbance event, and you can see it's moved quite a bit, not surprisingly. But then within the space of about 10 years, the coral reef's kind of taken this little route, but then by 2009, it's very close back to the 1993 level. So that kind of indicates a resilient system. Whereas when you look at the deeper sites that I showed you where it sort of declined, you see it all going in kind of one direction. So suggesting that the deeper sites are really not very resilient. And almost certainly with the deeper sites, what's happened is the reason why coral cover is going down there is because there's just simply not enough light. And there's enough light for corals to survive, but a lot of the species won't be able to tolerate that. And particularly when you get periods of very high turbidity, because it varies a lot here from week to week, you'll get corals dying out. And once you go deeper down in Singapore, when you go down to about 9 meters, there's basically no hard corals living at all. Okay, so all right, so what we've looked at previously is just looking at overall cover of hard corals, seaweeds, and so on. And certainly for the shallow side, that seems not to have changed dramatically. But it's possible that even if the overall coral cover hasn't changed, then maybe the structure of the taxonomic structure of the community might have changed. It might have gone from being dominated by one type of species to dominated by a completely different type of species. So we looked at that as well. And this is kind of what typical Singapore reef looks like now, with these corals that are mostly sort of foliaceous or massive or encrusting. And again, we can do the same type of multi-dimensional scaling plot. And again, you can see pre-disturbance and post-disturbance. This is again the 1998 disturbance. There has been a change, there has been a shift, and it doesn't seem to have sort of gone back again. But when I looked in a bit more detail at the actual data, it's not a dramatic shift in the species composition. One of the big things was the loss of a particular genus of coral called Montipora, which is an encrusting species, and that's reduced quite dramatically. And some other kind of foliaceous species have sort of increased. But what hasn't happened is it hasn't shifted from a system dominated by kind of, say, branching corals, which you would typically see like on reefs in Tiaman, to a system which is dominated by foliaceous and massive corals. I think even back in the 80s, it was dominated by these types of species. And again, the deeper sites have sort of taken a bit more of a unidirectional kind of change. So is it possible to go even a bit further back before surveys started? Well, we didn't think so, but until actually a few months back, NUS Museum contacted a bunch of us because they were doing something on an exhibit on Raffles Lighthouse, and they came up with and found that in 1950s, the famous Hans Haas, I don't know if all of you know of him, he's sort of like Jacques Cousteau's era and a bit before. And he went round the world making films underwater, and he visited Raffles Lighthouse, which is one of our main research sites. And it's a very small site, so we can be absolutely confident that when he filmed that site, he's filming almost exactly the same area or very similar area to where we do our surveys. And I haven't got the film, and it's wonderful to watch. But what I found really interesting, when I first watched it, I was really excited, and I expected to see lots of branching corals and it being a really different system, but it actually didn't look that different. There was a lot of foliaceous and massive corals even then. And I suspect, well, almost certainly what we're studying is what we call a shifted baseline. It's the system that we've studied now and even in the 1950s is very different from probably what it was 200 years ago. I liked your nice kind of summary history there, talking about what it was like at the beginning of the 19th century. And probably the reefs were very different there, but we can only go back to that by doing coring down into the substrate. And I think even at that time, there were all sorts of impacts like this. I found this wonderful picture in one of the books, which is somebody collecting corals in Singapore, again, probably around in the 1950s sort of time. So all those impacts were happening even then. So what about fish? So what's the sort of reason for this sort of resilience? And so one of the things we did was to look at fish and herbivore abundances. And one of the key things that you can get from this is that we don't have a lot of herbivores. The most dominant group here is this Cesionidae, which is a fusilier. So these are little fish that swim around and eat plankton. So this is not a system that's dominated by big herbivores. So this is not one of the things that's maintaining resilience in this system. We also did some sort of tethering studies to show bite rates, and you can see this was in sort of bite rates per hour on bits of tethered algae, and you can see there was about 0.2 bites per hour, and Peter would be pleased to know that it was all done by a crab and not by a fish. Whereas if you compare that to Ningaloo Reef, you get something like 195 bites per hour. So one of the possibilities actually that the system is structured by light, and it may just be when you get down to sort of the area where the corals are that seaweeds just don't do very well, and that's why they don't grow down and overtake the coral area. And Karen actually has some data to support this, showing that looking at sort of compensation depths for seaweeds and corals. The other thing is that the corals appear to be quite thermally resistant. So during the 2010 bleaching event, lots of corals bleached, but within a few months many had recovered really well, and certain species that typically bleach weren't bleaching at all. So I'm just going to sort of finish by saying, marginal reefs like those in Singapore can be very resilient, and that kind of changes the paradigm, I think, a little bit about what we know about reefs. And I think in terms of the predictions for reefs globally in the future, I don't think reefs are going to disappear as some people like to predict. They will change definitely, but not disappear completely, because actually they're pretty resilient sometimes, and they're good at adapting and acclimatizing. I think on the negative side though, I think Singapore reefs have probably lost a lot of their economic value, and that's I think quite important. So I mean, you don't get people coming here to go for diving tourism. I mean, people don't depend on Singapore's reefs as a source of food as they do in places like the Philippines. So I think that's an important point. And I think then to sort of maintain that kind of value, and to make people sort of feel a sense of value in things like the marine environment and the coral reefs, is that we must sort of continue to raise awareness. We must make people aware that the marine environment and Singapore's coral reefs are just as much a part of the natural heritage of the country as is the forests or Chinatown, or all those areas. And I think that has happened. I've seen that happen in the last decade, that people are much more aware of the marine environment than they were 10, 15 years ago. And I think it's important to sort of continue with that. Okay, thank you.